Okay, so if my general roots of the cubic are alpha, beta, and gamma, then I can write the cubic in factored form and equate it to the general form of the cubic. So the general form of a cubic is ax cubed plus bx squared plus cx plus d. And then that's identically equal to the factored form x minus alpha, x minus beta, x minus gamma. Okay, the issue is on the right-hand side, we've got a monic factored form, obviously. So we need to divide the left-hand side through by a in order to compare it. So I get x cubed plus b on a x squared plus c on a x plus d on a. And that's identically equal to x minus alpha, not infinity. X minus beta, x minus gamma. Okay, now if I'm going to compare, if I'm going to equate the coefficients, I'm going to have to expand the right-hand side. So I'm going to work with the right-hand side separately. So I'm then going to just say right-hand side is equal to, and I know from the expansion of the quadratic that the expanded form of the first two brackets is equal to x squared minus alpha x minus beta x plus alpha beta, and that is multiplied by x minus gamma. So then I'm going to multiply the x through from the second bracket into the first bracket. So I get x cubed minus alpha x squared minus beta x squared plus alpha beta x. Then I need to multiply the first bracket through by minus gamma. So I get minus gamma x squared plus alpha gamma x plus beta gamma x minus alpha beta gamma. And that's my fully expanded form. Okay, so here's the actual entire polynomial. So I've got left-hand side is identically equal to this expanded form on the right-hand side. What I need to do is to tidy up the right-hand side. I need to look for like terms so I can equate coefficients without straining my brain. So I'm just going to work on the right-hand side again. I've only got one x cubed term, so that's not a problem. I have got 1, 2, 3 x squared terms, and they're all negatives. So I'm going to take a negative outside the bracket and add them. And they are all x squared. I then have, let's see, 3 x terms. They're all positive. So alpha beta plus alpha gamma plus beta gamma x. That's everything except for the constant. So the constant's just tacked on at the end, minus alpha beta gamma. Okay. I don't like it when the gamma falls off the page. Okay, that's it there. So that's the right-hand side. Now I can start my work with equating coefficients to work out what I can observe about the roots. So as I said before, we've only got one x cubed term, and that tells us that 1 equals 1. So fun fact. The first one that I want to equate is the coefficients of x squared. So from the right-hand side coefficient, I get minus alpha plus beta plus gamma equals, and then the coefficient of the x squared on the left is b over a. So if I divide through by negative, I get the sum of the roots of a cubic is equal to minus b over a. Now this should hopefully be very familiar at this point because the sum of the roots of a quadratic was minus b over a. So this is good, this is good. Okay, so now I'm going to equate the coefficient of the x term. So I've got alpha beta plus alpha gamma plus beta gamma equals, there's no negative there, so that's fine, equals c on a. Now, this the C on A for the quadratic was, we called that the product of the roots because it was, but this in a cubic is called the sum of the roots because there's a plus sign between the terms. The sum of the roots taken 2 at a time. So you've got 2 at a time as in alpha, beta, and then another 2 alpha, gamma, and then another 2 beta, gamma. So this is the sum of the roots taken 2 at a time, which can also be used to describe the quadratic alpha beta equaling C on A, because that is the sum of the roots 2 at a time. There just happen to be only 2 roots, so it's fine. So sum of roots taken 2 at a time, C on A, no problem. Last fun fact is going to be so fun that it comes in red. We will have the product alpha beta gamma equals minus alpha beta gamma, sorry, equals positive D on A. So then multiplying through by -1 gives us the following fun fact. So this is interesting. I seem to get like a pattern of negative, then positive, then negative, and so on. This you will find will continue through the quartic and the quintic and the so on and so forth. It will always be sum is negative B on A, product taken however many at a time, C on A, and product is negative D on A. And then you get E on A, and then you get negative F on A, and so on. So just be careful with your signs as you're doing these. Yes. All right, we got there.